We're about to. But we finally got.
All right, now I want you guys to stop. If I haven't messed with your heads enough yet, I want to introduce you to the infinity. What? I'm going to let you dangle for a little bit. Okay. Just so that we are all on the same page, tomorrow you are turning in the first 7 problems, round 1. You've already done, most of you have had a chance to get some pretty good traction on round 2, problem number 1. If you're nice to me tomorrow, I'm going to do round 2, problem number 5. That's more of an investment banking, and it's going to mess with your head in different ways. So what you're really going to have tomorrow night for homework is round 2, problem number 2, which I think is the comic book problem. Round 2, number 3, which is a basketball tournament problem. And round 2, number 4, which is a little bit of geometry.
Why do we have 2 number 3?
Why do you have to do number 3? Because why do you have 2 number 3s? Why do you have to call that out on video? Wait, why are you staying for detention tomorrow night? Okay, so here is the thought experiment. Do not use your calculators. I just want to put something up on the board and get your gut instincts on this. What is that going to be equal to? What is that sum? 1 plus a half plus a 4 plus an 8 plus a 16 plus a 32nd plus a 64 plus goes on forever into the other room, goes on forever past that. I keep adding on this infinite number of terms. I want an answer and why you think it is that answer. Miguel.
Times 2 plus infinity.
Times 2 plus infinity. So that's what you think the answer to that is, and you think that because?
Well, I guess since it's going off of error, it's going to be infinity, and then the ratio is times 2.
The ratio is?
Times.
The ratio is? 1/2. Times 1/2 maybe?
Yeah, but.
Yeah, but. Okay, so can we fix what you wanted to say over here?
Yeah, times 1/2 plus infinity.
You're saying that the answer is going to be you multiply by a half and you add infinity. Okay, that's a thought. Kimmy.
I said 2.
You think it's going to be 2?
Yes.
Why do you think it's going to be 2, Kim?
Because like every time you have it gets smaller and smaller, and eventually the zeros are going to be the same. Okay. The 1/2 is going to.
Oh my goodness, that's. You guys, okay. Hey, sorry. So you think it's 2 because you start with 1 and then you add a half, and then what?
And then like it's just gonna.
Okay, you think it's going to be 2. Erica, you want to take a shot?
Yeah, I agree with you. I think it's going to be 2.
But can you explain why you think it's going to be 2?
Okay, because all the numbers after 1,
Yeah.
they like equal 1 because you keep halving it, half and a half. Half. Yeah.
So I start with the whole,
Yeah.
and then I add a half. Is that 2?
No.
That's not 2.
No.
But then I add a 4th. And it's still not 2. But I add an 8. Am I 2? No. But you still think it's 2. Any other thoughts out there, Jarvis?
I think it less than 2.
You think it's going to be less than 2? Not sure what, but less than 2? Depending on what?
It'll never reach 2. Okay. Since the numbers get smaller and smaller every time.
Okay. Okay. Michelle, what do you think? No, that's not a number.
I think that's into as well because you're adding 1 plus all of these fractions which are never going to be 2/2 or 1/1 to make 1 completing, so it's always going to be less than 2.
Okay. Kiara,
I agree with both of them because it's like the exponential function. When you have an asymptote, it always goes to and never reaches it because it's to the power.
So we seem to have some people that think it's going to be exactly equal to 2. Some people that think it's going to be a little bit less than 2, and some people that think it's going to be infinity. Do you know?
I think infinity.
You think infinity. All right, so just a quick show of hands. How many of you guys want to say it's going to be infinity? How many of you guys think it's going to be 2? How many of you guys think it's going to be something less than 2? How many of you guys have no idea, but you're hoping that the answer is going to come out of my mouth for the next minute and a half? There we go. Okay, new way to think about this. I want to think about this from a geometry standpoint. I want to start off with one whole box. Shade it in if you need to think about it. What does that represent? That represents the first term. The first term is one whole box, one whole candy bar. Now what do? I add on to it a half of a box. So if I take this full box over here and I add on a half, that's what I just added on. Right? This is one whole. This is the 1/2 I've added on. That takes care of the first 2 terms. Now what? How do I add a fourth?
You add half the top.
It's half of the top piece. Half of this top piece is going to be a fourth. How do I add on an eighth? Half of that would be an eighth. How do I add on a 16th? Half of what's left. How do I add on a 1/32nd? Half. 1/64th? Half. You guys figured out the pattern really well. 1 over 128. Half. If I repeat this process forever and I never stop, never, ever, ever stop. I keep going. I keep cutting it in half and half and half and half and half and half and half. What am I going to get? In the limits where I actually approach infinity, this is actually going to be not infinity. See you later. Good luck wrapping your head around that tonight. I said 2. I like the number 2.
That's so dangerous. Oh no. Without you, that's smart.
It's your fault, Maria.
No, because I thought this was history.
We were doing our
Yes, ma'am. Good question. How many answers? It is the sum.
But I have to find A and first.
Yeah, so you're going to have to go back however many generations I said, 13 generations, 15 generations.